When I was generously asked to give this talk, I got to tell some of my friends, hey, I'm giving this talk, Intro to Introspection. They said, that sounds fascinating. What's introspection? It's not a term we use so often around here, but for today, I like to define introspection as the ability to look at your code as it's running without having the source around. We're going to use introspection. We're going to ask questions of a running program, and we're going to get answers, hopefully. So if we're going to ask questions, what are we going to ask? The three main questions, core questions, is what's even there? We have no subjects for the rest of our inquiries unless we can name something that's in the program. So we have to know what's there. Once we have some names, we can ask the sort of fundamental inheritance question, what is it? What created this thing? What's its type? What are its parent types? We can also ask the more fundamental composition question, what does it have? So maybe you know what shape it is, what class it is, but it's unfamiliar to you or you just don't understand it enough. You also want to know what attributes it has. What can you get out of the thing? So if you ended up in a strange program that was running, you had no idea for how long, you didn't know at what point in execution it was or what its purpose was, how would you start exploring this space? If all you saw was 3 chevrons, what would be your first step in exploring this code? My first step will be to call locals and say, what's around? Locals will helpfully respond, these are your local names. There's not a lot, just a couple, and a lot of them are empty, so perhaps of no interest to us right now. I could also ask globals the same question, and I get the same answer. So getting the same answer from locals and globals combined with this line here, name is main, kind of confirms my initial suspicion that we're actually in the top level interactive Python REPL. The main module is the one that launches the Python program. And you'll be familiar with the name main if you've ever had to write out the mantra if name equals main in any of your scripts. So the only other strange name around here is this guy at the end, who I've never seen before. I don't know what he's supposed to be doing, but it's somewhere to continue our investigation. So we figured out what's around. The next basic question is, what is it? Type, what is Shy's type? It is of the unknown class. Perhaps not that informative. We don't know what this class is or what it does, but this information does tell us that Shy is an instance of this class. So we have an instance of a class, and we have another name to also use in further inquiry. The third of our core questions is, what does it have? So I'm unfamiliar with this type. I don't know what unknown is. What can I do with Shy? Dir says Shy has a hint attribute. Sounds helpful. What's your hint, Shy? I guess it qualifies as a hint. Still being quite cryptic here, but there's another built-in callable. If you pass it any object, it tells you, is this thing callable? That is, if it is a callable, that means it makes sense to put parentheses after this object and expect some code to actually be executed. And you don't know if it'll work or not, but it is a good line of questioning. So Shy is callable. Yes. We call it. It doesn't seem to do anything. But we didn't get any errors, so it is in fact a callable. It perhaps did something, but we don't know what its purpose is yet. We've also kind of run to the end of the tools that are available to us that, as we're in the top level module. So to find out more about Shy, we're going to have to get a little extra power, and we're going to use the inspect module. So it might not be too surprising that a batteries included language such as Python has a module specifically for introspection. They call it inspect. And it is all for investigating your code at runtime. It has many dozens of really handy functions. We're going to get through just a couple today. So before we had inspect, we could ask what Shy's type is using built-ins. But with inspect, we can use this getMRO function, which basically says, give me the entire lineage of Shy. And we get a slightly different answer. We can see that Shy comes from a known, but it has a long lineage of classes that goes all the way back to object. So shy is an instance of a class that is a child of another class, and it's actually a melding of all these different things. Before we had inspect, we could ask dir, what does shy have? And we were told hint. With inspect, we can ask the same question, and we get mostly the same answer. It told us the value at the same time, which is kind of nice. But inspect is capable of pulling out other information from an object. We can ask for its doc string. We can ask what module defined this class. Maybe unsurprisingly, since shy was a local, its class was defined in the local module. But shy isn't just an instance, it also contains all the information that was in that lineage of classes. So if we ask what are the members of its inheritance that inherits from those classes, we get this actually very long list. It goes on for a couple pages, sorry. But this is everything that shy has access to because it is a member of these classes. If you look a little closely, you can see it's actually inheriting methods from every one of its parent classes, even including object. So it is a melding of all these classes. So to understand what shy is doing, we have to at least somewhat understand what all of its parents are trying to do. And it's not only methods, also data is attached through this parentage, like the doc string that we just got. I'll clean this up a little bit so it actually fits on one slide. This is just the names. This is every name that shy has access to because of that inheritance. The last place we got stumped when we just had our built-ins was shy is a callable, but we didn't know what to do with it. Inspect has this function, which I think is inspect's real superpower, signature. You give anything that's callable, which we confirmed by using the built-in callable, and it gives you back a signature class that has lots of ways to really dissect callables at runtime and get precise information. But just the representation of this class as printed back to us on the REPL alone is enough to basically tell us how to call it. So we can see that actually shy has 4 parameters. They all have defaults, which is why it worked without any of them. And whoever wrote this method gave us some type hints, which are preserved at runtime. So before we called shy, we got no answer. But it appears to be locked, so we could try unlocking it. We still don't get an answer, but we get a different no answer. Next, it wants a message. So we could try passing hello, but it's not saying anything. So I'm not sure if anyone caught, but on the last slide, we saw that shy has attributes that match the names of these parameters. So if we line those up, then we start to see what maybe shy is capable of doing. So that was using inspect to figure out what's going on in this running code. But inspect is just a Python module. And by that, I don't mean it's a module for Python. We were just using it. I mean, it's written in pure Python. So whatever inspect is doing behind the scenes is something that you can write in your own code. It's something you could even write while you were, say, in an interactive REPL of Python. And if we can figure out just how inspect is doing its job, we could replicate it. And if we could replicate it, we could extend it to answer questions that is incapable of answering for us. So we're going to figure out how inspect does its job, but first I think there are 3 core ideas that you have to just understand before you start diving into your own code to try and understand it at runtime. You have to know where names come from, because we need a name before we can ask further questions. And then you have to know that everything's an object in Python. You probably heard this said before, but it's important when exploring these names to know that there are objects behind them. And then finally, attributes come not only from the thing itself, but also its inheritance, its parent classes. So scope. Python is lexically scoped, which means the value you get from a name is in code. But we don't have code. We only have the runtime. So we have to find these scopes. And names are resolved in local enclosing global built-in, which means first Python will look in the block of code that the name was written in, and then if that block of code is inside a bigger one, like a function inside of a function, or a method inside of a class, it'll look outside. And then it'll look in the module global scope, and if it can't find it there, it'll try one last time to look at the built-in namespace before throwing a name error. So the very first thing we did when we were in a strange environment is we asked locals for what was around, and it told us. But I don't know if you're suspicious to anyone that none of these answers were locals. So how did we call locals if it wasn't a local? This is in fact false. There is no enclosing space because we got the global scope. Locals is also not a global, so there's only one place left for Python to find it. Locals is in fact one of the built-ins, and built-ins is a local. So this is how we got there. Next important idea when introspecting is everything's an object. This is important because it means all objects have types and all objects have attributes. So this means it's always valid to ask of anything that you can name in Python, what is it and what does it have? Because there's an answer to both these questions. And the fact that everything has an attribute is important because the interpreter itself keeps all data it needs to know about your code inside those objects at runtime in attributes. These are usually called magic methods or dunders. And if you want to know what their names are and what they do, it is extensively documented in the Python data model, which is in the docs. It goes on for a long time, but if you use it, you can figure out when you see these weird, strange double under methods, what they're intended to do. And once you know what they're supposed to do, you know what the object you have is capable of. So we've confirmed already locals is actually a built-in function, locals. So this name resolved to this object, but this object can also be found by going through the built-ins module. It can also be found by going through the built-ins private dictionary, because attribute lookup in Python is really just a dictionary lookup wearing a mask. It's just syntactic sugar for opening up a private dictionary and pulling a value out. So how did locals actually do its job of telling us what's available where we are right now? We try and use a name dict to access our local scope. We get a name error because it was not, in fact, one of the locals that we had around. So this is going to be the one time today where the built-ins actually have a much easier time of it than we do. That locals is kind of a special compiled with the core and has access to this scope. We can get there, but it'll take us an extra step or two. We first need to grab sys, because inside sys is a handle to every module that Python has loaded in the current interpreter. Once we have a reference to ourselves through our special local attribute name, remember name is main, so now we have a handle to the module that we're also currently inside of. Once you have this, it also has a private dictionary, and that dictionary is the answer from locals. It has the sys added to it because we had to import it for this example. So again, we're just looking up keys in a dictionary. We are inside of an object, but we can also get a reference to that object. The last key idea is attribute lookup. So we've found out where our names are, but all names have attributes. Those attributes are looked up in a private dictionary, but if it's not found there, that's not the end of the story. You don't get an attribute error immediately. Python will then begin looking up your lineage. It'll look in your class, and it'll look in your entire MRO, which we saw with the inspect method get MRO. It was actually an acronym for method resolution order. Despite the name, this is the order that all attributes are looked up. So you check the thing that you asked for the attribute on. If it's not there, you check its class, and you go all the way back to object. If you can't find it, then you get the attribute error from Python. So when we asked inspect to give us the members of Shy, it told us both the names and the value. But we could have always just looked inside its private dictionary. There is the hint that we saw, but there's also those other attributes which we actually ended up using when we called it as a function. They were all just sitting there in this private dictionary, and they can be accessed through an attribute lookup. This huge, long list comprehension was what what inspect told us was available on Shy because of its inheritance. So this is, again, we found the values on the instance, but we also have to go through all of its classes. To get the same information without using any built-ins or the inspect module, we first have to recognize that any object's type is really just the class that created it. So that's the same thing. That class is an object, so it also has a private dictionary. So the unknown class, this is everything that was defined on it when it was created. All the methods were ones that were created for it. This is still none of the inheritance. So we haven't finished the story. We found the instance's attributes and its class's attributes, but it has a much longer lineage of classage all the way back to object. So we're not done. We have to go back to the MRO so that we can check every one of these classes. Another way to get the MRO is through that class again. All types have classes. All classes have an MRO because everything has some level of inheritance. Now we will have to walk all of these, and for each one, look inside their private dictionary. Now this list is much longer than what inspect gave us because there are duplicates. These classes can define the same thing, and at runtime, you override your parent's attributes. So we'll have to clean this up. Instead of a list comprehension, if we just do a set comprehension, and if we sort it, we get the exact same output that inspect told us. Finally, I said that inspect's, I think, superpower is this signature callable. When I don't stop to think about how hard inspect works for me, I usually think getting the information of a callable at runtime is very easy. It's usually defined on a single line, even with type annotations, 1 or 2 lines. It's all right there. We're used to reading it at a glance. But at runtime, all this information is scattered way over the interpreter, and finding it is actually quite an ordeal. First, we have to go to our data model to understand that classes that define a call method make their instances callable. So this is the real function that's deferred to when you call Shy. The next thing we have to understand from our data model is that all functions have a code object. This is the thing that's jumped to by the interpreter and executed when you execute a function. So even our code are objects. So they also have attributes. This var names are the parameter names. We've dug so deep into Python that any of the syntactic sugar is virtually gone. We see that actually it has 5 parameters. The first one's self because it is a method. So we just have to kind of deal with that. But we still haven't replicated the power of signature. We want to know what the defaults are. That is in an entirely different object on call, defaults, aptly enough. But this is just a tuple of defaults. We're going to have to match them up with the parameters they belong to ourselves. And we're still not done. We still don't have any of the helpful type annotations. Those are in another object, which is a different data structure, and again needs to be matched up with the prior to. If we combine all this, we get back just what the representation of the signature class alone was able to tell us. But we can find it ourselves. So now we figured out how inspect does its work behind the scenes. We can take the same approach, and when it can't answer questions for us, we can use the same techniques to answer our own questions. So an early question we asked was, Shy, are you callable? And it said yes. But a question that inspect is not capable of answering, at least not right now, is the thing indexable? Callable means it's a good line of questioning to put parentheses after this object and try and invoke it. Are you indexable means, should I be putting square brackets after this thing and trying to get data out of it? Or is it just forever going to give me an attribute error, type is unindexable? Once I formulate this question, which again, the data model tells me what things I need to look for. It's kind of unintuitive, but you just have to read. We can ask this question of Shy. It says, yes, I am callable, but I'm also indexable. So here's another line of inquiry we can take with it. We try to index it, and we get an exception. But it's not an attribute error, it's an index error. So we just don't know what range Shy wants to deal with. We're out of range. The key with Shy as a callable is to use its own attributes. So if we try that again, stop getting exceptions. We're still not getting the answers we want, but I guess there's still a little more to figure out about Shy. Even though we haven't figured out everything with Shy, we are done with introspection for today. So there are 3 core questions. What's even around? Scopes are resolved in leg B order. What is it? Everything has a type, which is a class, and all classes have an inheritance tree. And then what does it have? Everything has a private dictionary, including those parent classes. How do you answer these questions that you want to ask of your code that's running? The built-in module is very helpful. When I started to form this talk, I looked through, and by my count, about 1/5 of all the built-ins are exclusively or primarily useful for introspection. So it's kind of just built right into Python. But if there's not enough in the inspect module, or excuse me, in the built-in module, you have the inspect module that has more power. But if you still can't answer your questions, you can take the data model as your map, and you can go off spelunking in your own code and get your own answers. Thank you.